Hello, so we're going to be going over lesson 11, ratios of fractions and their unit rates. Make sure to copy everything that I'm writing down, and anything that I say that you think would be good notes, just make sure these are very good notes and copy as much as you can. I'm going to be going over all the problems except for the problem set. The problem set will be your homework to make sure you understand this. Now let me give you an overview of what you need to know in order to be able to accomplish lesson 11. You need to know that when you're making a ratio that you can that the easiest way to do this is making it y over x. So you have to determine on your variables which one's y, which one's x. And then we're going to actually solve. So when we solve, don't copy this part. We've done problems like this. Don't copy this part. Over here, don't copy this. So half divided by 3 over 4. We could have rewrote this as 1/2 divided by 3 over 4. So remember that we've already done this, so it's the same thing as what we've done before. And we would actually keep this the same, change this, and flip this, and then multiply across. This would become 4 over 6, and that would be your answer. Okay. So we're going to be doing the same thing with these numbers as well. Now on this problem, this is like 2 of those problems. Copy that down, like 2 problems. Okay, copy that down, and I'm going to erase this over here, just so then you don't get confused about copying that later. We don't want to have these numbers as an example, and then you think it has something to do with the example 1. So you should have like 2 problems and y over x so far. Now looking at this, if you need to pause the video, take out a highlighter. During their last workout, Izzy ran 2 1/4 of a mile in 15 minutes. So we're going to have 2 1/4 mile in 15 minutes. And this was for Izzy. So we'll highlight the I. And her friend Julia, will highlight the J, ran 3 3/4 miles in 25 minutes. So I can already tell, nice thing about math, you see numbers are probably important. And sometimes they try to trick you and they are numbers that you don't use. But highlight it anyways, because later you can find out if you're going to use it or not. Each girl thought she was the faster runner. Based on their last run, which girl is correct? Use any approach to find the solution. So let's look at the first problem. So this one here is like the first problem, and this one's like the second problem. Okay. So on here, we're going to have, well, which one would be x? Well, remember in class I said time is always your x-axis, which makes this one your y. Now that we have that, all we have to do is plug in. So your y is equal to 2 1/4. Okay, so where am I getting that from? Right here. Bring it down and put it where your y is. And then 15, bring it down and put it where your x is. And this will give you 2 over 1/4 divided by 15. This is now equal to, well, this makes it hard since it's a mixed fraction. So we want to change that to where we actually have this as an improper fraction. So we're going to multiply 4 times 2 and add the 1. And this gives you 8 plus 1 is 9. 9 over 4 over 15. Now, check your answer. 4 goes to 9 2 times and 1/4 left over. Yep, so we did that right. And now we're going to rewrite. So let's write rewrite. And we're going to say 9 over 4 divided by 15 over 1. And we will say keep, change, and flip. This now becomes 9 over 4 is the same. Change this to multiplication and flip this. And remember, flipping is taking a fraction and doing the reciprocal. Okay, so remember this is called the reciprocal. Taking the top, making it the bottom. Taking the bottom, making it the top. Fraction times fraction, just multiply across, and this becomes 9 over 60. Divide by 3, divide by 3. Equals, 3 goes to 9, 3 times, 3 goes into 60, 20 times. So this is now 3 over 20. So that is our first one. So remember I said this is like two problems. Now we're going to do the same steps for the second one. So if you'd like, pause the video, try it out with the second one, and see if you understand this so you're ready for your homework. So hopefully you paused the video at that point, and you're ready to start working. So now this one's y over x. We're going to have to say which ones are x. So minutes, time is always your x, and miles is your y. Plug this in. This is 25 all over. Oh, why am I doing that? Hopefully you caught that too. So 3 3/4 is your y. Let me do the same thing as before. So this one is 3 3/4 is your y. Plug that in. 25 is your x, and plug it in there. So this becomes 3 3/4. Change the color. All over 25. Multiply and add. 4 times 3 is 12. 12 plus 3 is 15. 15 over 4. And divide by 25. Now that you have this, we're going to rewrite. Rewrite this. This becomes 15 over 4. Divide by 25 over 1. And now we're ready to say keep, change, flip. Now remember, this 25 over 1 comes from this 25 here. Putting over 1 makes it a fraction. So now it's 15 over 4. Multiply 1 over 25. Multiply across. 15 times 1 is 15. 4 times 25 is 100. And we're going to divide top and bottom by, or actually, let's not divide top and bottom. So this is, we could reduce this. Okay, let's reduce it. All right, so what number goes into 15 and 100? I see right away 5 does. So we don't have to find the biggest, we just need to start somewhere. 5 goes into 15 3 times. 5 goes into 100, how many times? 20. Oh, we actually did find the biggest. So this one is 3 and 20. What do you notice about the two rates? Now before we go on further, let's talk about what these rates even mean. If you notice, the y was miles, so this is actually miles here. The x was minutes. Same thing over here. This was miles, and this one was minutes. Make sure you copy that down. Do that now. If you have miles there, then over here, you should have miles. If you have minutes here, then on the bottom of this fraction, you should have minutes. So this one is miles, and this one is minutes. Now same reasoning over here. This one is miles, this one is minutes. Alright, copy that down. Now if you don't have this many highlighters, different colors, that's fine. You don't have to highlight like I did. Just know where I'm getting this from. So I want you to connect these dots as you're learning this. Well, we know these are the same. Now we got to talk about what it means. So I want you to write what it means. For every, and then start with your time, 20 minutes. How much do you travel every 20 minutes? Do you have an answer? Take a pause. Alright, so for every 20 minutes, you travel, based on here, 3 miles is how you're reading that fraction. So this ratio is telling me for every 20 minutes, you travel 3 miles. Now they both travel 3 miles for every 20 minutes. So each girl thought she was the faster runner. Based on their last run, which girl is correct? Use any approach to find the solution. So we found that their rate here is actually the same. So they're running at the same rate. So they could actually be running side by side, is what this means. So here's your starting point. And they both actually arrive at 2 1/4 miles at 15 minutes. So both of them arrive at the same point. Then one of them stops there, but the other one actually just keeps on going. Oh, that's two on top of it. The other one actually keeps going to where they stop at 25 minutes. And at 25 minutes, they actually travel 3 3/4 of a mile. So they're running at the same rate, just one stopped before the other. So think about Izzy and Julia. They could be running side by side because they're running at the same rate. Okay. All right, let's go on to the next one. And there are more methods to solve this, but for sake of time, we're going to stop at this method. And to understand the problems that follow, this is the method you want to use. Example 2, is Meredith correct? So a turtle walks 7/8 of a mile in 50 minutes. What is the unit rate expressed in miles per hour? So part A says to find the turtle's unit rate, Meredith wrote the following complex fraction. Explain how the fraction 5/6 was obtained. They're still using what I showed you as y over x for the ratio. They're taking the minutes is your x, and this is your y. So they're plugging in your miles should go over here, and your minutes should go over here. So this is miles, but this is minutes. But even the problem brings you to a dilemma. You have 5/6 minutes. So why would I write 5/6 minutes? That's not the same number as 50. So maybe I don't label this minutes any longer. Why do you think they went from 50 to 5/6? The problem even asks you, explain how the fraction 5/6 was obtained right here. So let's look at that. We start with 50 minutes. Then we have 5/6. How could I make that 5 of 50? Well, I could put a 0. If I put a 0 there, I need to put a 0 on the bottom. But now it's 50/60. Where do you see 60 in a unit of time? Well, I see it in seconds, so 60 seconds. Do I see 60 minutes? Yeah. And 50 was minutes. So if I have minutes here and minutes here, what is 5/6 representing? Think about it for a second. Alright, hopefully you have this guess. This is what it represents. They're converting this to hours because basically if you draw a clock, this is at 50. That looks close enough. This is out 50 minutes out of the 60 possible on your clock. Okay. So there's 60 minutes possible. Sorry, I want to make this look nice. And you have 50 possible out of all 60. But they reduced it after they did the 50 out of 60, and that's how they went back to 5 out of 6, because they divide by 10 top and bottom. So copy this down as your explanation, and say they used 50 minutes out of 60 minutes. This would be 5/6 of an hour. Okay, have that copied. Now determine the unit rate. So now we're on to the unit rate, this problem. Continuing this one from A. All we have to do is take 7/8, divide by 5/6, and rewrite and work it out. So try to rewrite it before I do. Pause it and work on it. Alright, hopefully you have this. 7/8 divided by 5/6. 7/8. So we're doing keep, change, flip, multiplication. 6/5, remember the flip is your reciprocal, so you're actually moving that. And now we're going to multiply. 7 times 6, 8 times 5. This is 42/40. And we can reduce top and bottom. So I'm going to divide by 2. This is 21/20. Now to figure out what the unit is and make sense of this problem, we're going to look at, this was miles on the top, and this one is hours on the bottom. I should write hours over here as well. So this is miles as well, and hours. I'm going to have to rewrite it, or actually, since I'm in the computer, I get to cheat. You have to fit it in. I'm going to just move it over. Miles and hours. Okay, look at number 1. Make sure you have everything copied. For Anthony's birthday, his mother is making cupcakes for his 12 friends at his daycare. The recipe calls for 3 1/3 cups of flour. Okay, let's highlight that. 3 1/3 cups of flour. This recipe makes 2 1/2 dozen cupcakes. Anthony's mother has only 1 cup of flour. Is there enough flour for each of his friends to get a cupcake? Explain and show your work. Right. So the way that I teach this one, because we could find the unit rate by, well, let's see what we get from y over x and see if this solves our problem, and then I'll show you another way if it doesn't. So on this one, we have 3 1/3 cups of flour, and this recipe makes 2 1/2 dozen cupcakes. Now here's the issue that I'm running into right here, which is why we're going to actually use a different formula. On this one, I can't figure out which one's my y and which one's my x with confidence. My guess is that this one is your y and this one is your x, and I'm pretty sure that I'm right with it. But let's say you didn't know. Then you would want to use a different formula, and I feel like this formula is so much easier. So this one is going to be unit 1, and we've done this before, so it's nothing new. Unit 2 equals unit 1 over unit 2. Now we know that we're dealing with cups and cupcakes. Actually, dozen cupcakes. So I'm going to put cups, and I'm going to put dozen cupcakes. Equals, and then I have to use the same unit, so cups, make a little bit of room on the left, over dozen cupcakes. Copy that down. Now, this one says 3 1/3 cups, so I'm going to put 3 1/3 here, and then this one says 2 1/2, so I'm going to put 2 1/2 here. I have to put them on the same side because that's where our ratio is. She only has 1 cup of flour, so do you think I put it here, cups, or a dozen cupcakes? Cups, of course. And then, is there enough flour for each of his friends to get a cupcake? Alright, so we got to find out the answer. Now, we don't know how many cupcakes, so we're going to put an x here. So we can cross multiply, and we'll find out that 3 1/3 x is equal to 2 1/2, and divide by 3 1/3, and this gives me x and something else, right? So whatever this is, we got to work this out. But I want to stop you right there because look, if you notice, this tells us what our y is and what our x is. Let's see if I was right. Yeah, this is my y, this is my x. So these formulas help you in both ways, but sometimes you can't tell what your y and your x is, like this kind of problem. So you want to use this problem here. It's the same kind of setup. You're still doing division, but you know for sure that you chose the right y and x, because if you choose this wrong, you won't have the correct answer. So now let's work this out. This would be 2.5. 2.5. Multiply and add. This is 4, 5 over 2, divided by, and then multiply and add. 3 times 3 is 9, plus 1, 10 over 3. So this is x equals, I'm going to write it over here because I ran out of room, 5 over 2 divided by 10 over 3. Keep, change, and flip. This becomes 5 over 2 times, and then 10 over 3 reciprocal, 3 over 10. Multiply across, 15 over 20. And we can reduce. So x equals, and we now have divide by 5, divide by 5. 5 goes into 15 3 times, 5 goes into 20 4 times. So this is 3/4 of what? What was it? So to figure this out, you have to look back at your work, see how x was with dozen cupcakes. So over here, that tells you what to fill in. So this is now dozen cupcakes. Okay? Alright, so pause the video if you still need a copy. Let me zoom in so you have a good shot of it. Pause the video here if you need to copy whatever you missed. And rewind if it is not making sense. You don't watch this one time. Rewind, watch it again to make sense of it. Okay, next one. I'm actually going to put the next one in another video. We only have problem 2 left, and then you're ready to start on your problem set. So watch part 2 on this video. Actually, let me see. Let's look at the problem set. So you have determine the quotient. Alright, so you know how to do this. You're going to change this to improper. Keep, change, flip. 1 lap around a dirt track is 1/3 mile. It takes Bryce 1/9 of an hour to ride 1 lap. What is Bryce's unit rate in miles around the track? Okay, so this is very similar to the problems we did there. Mr. G, we'll call him, wants to make a shelf with boards that are 1 1/3 feet long. If he has an 18-foot board, how many pieces can you cut from the big board? This will be your unit 1 over unit 2 equals unit 1 over unit 2. So if you want to cut this, you're trying to figure out how many times can you fit. How many can you fit into an 18-foot board? So you just need to divide this. Same as if I made this a 2-foot board, you would automatically tell me the answer is 9 feet. So all you're doing is 18 over 1 1/3. The local bakery uses 1.75 cups of flour in each batch of cookies. The bakery used 5.25 cups of flour this morning. How many batches of cookies did the bakery make? If there are 5 dozen cookies in each batch, how many cookies did the bakery make? Okay, this is a very similar problem to the one we did with the mom. Has cups of flour, and she has 5.25 in each batch. So this is per batch. So this is actually a 1. So she makes 1 batch of cookie on this. So you need to use this formula. Unit 1 over unit 2 is equal to unit 1 over unit 2 to figure this out. So cross multiply after you do this. It looks like you may have to do multiplication instead of division, so make sure you use this to figure out if that's true. Jason eats 10 ounces of candy in 5 days. How many pounds will he eat per day? And recall that 16 ounces equals 1 pound. This one, you are not using unit 1 over unit 2 equals unit 1 over unit 2. You're using instead that you have how many will he eat per day. So you have 10 ounces. Okay, this one's a little tricky. You're using a couple things. And then this one's 5 days. How do you change this to 1 day? Right? So how many ounces is in 1 day is what you need to find out first. Then you need to take this, bring it down, and you have to multiply it by this fact here. And you have to think, do I put ounces on top or on the bottom, pounds on top or on the bottom? And then how long will it take Jason to eat 1 pound of candy? So this one is definitely a challenge problem. Do your best on this. So I went over that to make sure that you are set up without this last problem because it seems like more of the same thing. So if you would like me to go over this in class, let me know. This will be collected on Wednesday. So you need to finish the problem set and everything that I wrote, you are copying. Okay? Let me know if you have any questions in class, please.